Welcome to Study Loop.
Let's evaluate the given integral. Here we should do a partial fraction decomposition, and looking at this quadratic equation in the denominator, this quadratic expression, we'd like to know whether or not this factors. So here we use the discriminant, which is b squared minus 4ac. So this expression is coming from a generic polynomial of degree 2. So we'll check b squared minus 4ac, and if this is less than 0, then the quadratic does not factor. In our case, b is 0, a is 1, c is 9, so we see b squared minus 4ac is negative, and that means the quadratic doesn't factor. So for the linear factor, we have a over x minus 1, and then for the quadratic factor, bx plus c, x squared plus 9. Now let's take this latest equation, multiply both sides by this denominator on the bottom left. We get 10. A x squared plus 9 plus bx plus c, and then x minus 1. Here we should just go ahead and factor out x squared. So first let's just simplify this right hand side. We get ax squared plus 9a plus bx squared plus cx, and then we have minus bx and then minus c. Let's go ahead and factor out x squared. We have a plus b. Let's factor out x. Then we have c minus b. And then our constant term is 9a minus c. And from this, we can get a system of equations. So looking on the left-hand side, we don't see an x squared, so we can write this as 0x squared. We also don't see an x. Let's write that as 0x. And then we still have 10. So on the left-hand side, the coefficient in front of x squared is 0. On the right side, it's a plus b. The coefficient in front of x on the right-hand side is c minus b, but on the left-hand side is 0, so those must be equal. And then finally, on the left, the constant term is 10. On the right-hand side, it's 9a minus c, so those must also be equal. This means that we have a 3x3 system to solve in the variables or the coefficients a, b, and c. Let's go to the next page to solve the system. We had a plus b is 0, c minus b is 0, and then we also had 9a minus c equals 10. So let's go ahead and solve the system. I take this first equation. I could solve this for b. Take the second equation, solve it for c. And then I guess here in the last equation, we can solve this one for c as well. But since c equals b, we could go ahead and replace the left-hand side here. We have c, so we can replace that with b. But then we also know that b equals negative a from the first equation. So we have negative a equals 9a minus 10. This means 10 equals 10a. So a equals 1. And then from this equation over here, we get b. And since c equals b, c is also negative 1. So we found our coefficients a, b, and c. Let's go ahead and plug these into the partial fraction decomposition. So here, I'll need more room, so let me go to the next page to write this out. The integral now becomes a, which is 1 over x minus 1. And then we had b was -1, and then c was also -1, and then x squared plus 9. And here's our new integral. This will be easier to evaluate than the original problem. Let's go ahead and break this up into 3 integrals. So here I'll just break this up into fractions. This is -x, x squared plus 9, and then plus -1 over x squared plus 9. So we have integral 1 over x minus 1 minus integral x, and then x squared plus 9 minus integral 1 over x squared plus 9. And technically I should be careful here. I should put my dx each time. The first integral we can evaluate. If that -1 is bothering you, just to go ahead and do a u sub. But this integral becomes natural log absolute value x minus 1. So that's one of our answers. Now coming to the second integral over here with the minus sign outside, here we can do a u sub as well. U equals x squared plus 9. This means du over 2 is x dx, so that this integral becomes, we have a negative from the subtraction up here, we have the 1/2 from the u sub, and then we have integral du over u. That's -1/2 ln absolute value u, and then do the back substitution. Replace u with x squared plus 9 if you want. You can drop absolute value here because x squared plus 9 is positive. And then we have one more integral to go. This one also has a minus outside in the front, so beware of that. So for this integral, we'll need a trig sub. Let's go ahead and take x to be 3 tan theta dx, 3 secant squared d theta. So this integral becomes, we have a dx on top, on the bottom, we have 9 tan squared plus 9. Let me go ahead and factor out that 9 on the bottom. And this is -1 over 3. We have secant up top, secant squared. Tan squared plus 1 is also secant squared. So those will cancel. We'll have 1 over 3, integral of just 1 d theta. This is -1 over 3 theta. And now, to find theta, we just take our trig sub and solve for theta. Tan theta equals x over 3. Take arctan on both sides. That's your theta. So now we've evaluated all 3 integrals. Let's just go ahead and add our answers up. So I'll go to the next page to do that. So we have natural log x minus 1. That was the first integral. Then the second one, where we did the u sub, we had -1/2 ln x squared plus 9. Then the latest trig sub gave us -1/3 tan inverse x over 3. And then let's not forget that constant c of integration. And this is our final answer.